Hey guys, and welcome to another YouTube lesson. Today we're going to be looking at the business function of operations, and we're continuing with processes, those sets of steps that a business will complete during their operations day-to-day job. We're going to be looking at 3 syllabus dot points under the transformation process. And that includes this concept of scheduling and sequencing, technology, task design and process layout, and monitoring, controlling and improvement. All right, first off, scheduling and sequencing, or rather from the syllabus, sequencing and scheduling. It's important you know the difference between the two. One's the length of time and the other is the order in which the task will be completed. So sequencing is the order in which operations processes occur. So remember that. To sequence is the order. 1, 2, 3, and so on. That's sequencing. Whereas scheduling is how long each of these processes, these tasks will take in the transformation process. So it will take 2 minutes, 3 days, 6 weeks. Like a lot of my lessons seem to go on forever and ever. That's the length of time. Now, there are 2 key ways to sequence and schedule the operations of a business, and that's through a Gantt chart, the use of a Gantt chart, and also through the use of a CPA, critical path analysis. Now, Gantt charts. This is one of the most common scheduling techniques, and it's called a Gantt chart. A Gantt chart records the number of tasks involved in each particular project and the estimated time needed for each task. It is used so that managers can plan and process accordingly to improve their efficiency, to make sure they can get as much done in as limited time as possible. Now, you would have seen Gantt charts before in the textbook, and they'll often have something like, it's like a table, and you'll have a number of different tasks that need to be completed. And you'll have things whereby you have the first task might be done in weeks, and the first task might take a week or 2 weeks. The second task might take the same amount of time, but the good thing about a Gantt chart is that you're able to complete some of that second task during the first task, and you'll see it below where it starts. So you have to complete task 1 on its own for a while, and then you're able to complete task 2 maybe half a week into that. And it's a way to be able to see what order tasks need to be done, how long each task will take, and more importantly, what tasks at what stages can be completed concurrently, which means which 2, 3 or more tasks can be completed at the same time. So if you can do a number of things at the same time, then you're able to get the overall job done more quickly. Now, the other way to be able to schedule and sequence is through critical path analysis, CPA. A critical path is a planning tool intended to assist with the scheduling of operations by delineating, how long necessary activities take place and showing what again can be done concurrently at the same time. Now, this is the written short answer definition I want you to say in a test. I'll tell you now. Right, but note, to figure it out mathematically, I'll give you another definition. You never write down, but in your head, use that instead. Now, the written short answer definition is the critical path is the shortest path for completion of all activities, and it's constrained by the activities that take the longest. That's what I want to see written in your essays, in your short answers, multiple choice questions. If they have something like that, that's what you select. All right, now note again, some activities can be done concurrently, which is at the same time. Now, this is the maths critical path analysis. When you see your critical path analysis and you need to be able to find that critical path, the best way to find it is if you take the longest single path without being crazy and doubling back on things, then that's the best way to find that critical path. Why is that the case? Because if you take the longest, you find out whatever the longest single path is to get from A to Z or whatever it may well be, all right, and the other ones are all shorter, then you can complete those shorter ones in the time frame of that longer one. So never write that, but when you're figuring it out mathematically, that longest single path, that'll always give you the right answer in terms of 12 weeks, 8 days, whatever it may well be. Because if the shorter path for a 12-week one takes 3 weeks, another one 8 weeks, another one 7 weeks, then you know that you can complete those shorter ones in that time frame. None of that makes sense to you. Ask me to give you some examples and get you to practice it and get me to explain it to you again in class. All right, the next dot point is technology. Technology is another process of operations. Technology is a key input into this operations process. Now, there are 2 types of technologies in the syllabus. Those 2 technologies include administration and office technologies, and also technologies used in manufacturing. So office technologies, manufacturing technologies. Office technologies are used in the running of routine office administrative duties. Printers, computers, software programs, Microsoft Word, etc. Whereas manufacturing technologies are technologies that are specifically designed and useful for the actual production of goods. Some examples of those include computer machinery used in assembly and production lines. Now, some of the benefits of office technology include being able to use Microsoft Word, Excel, MYOB, and they're there to improve efficiency, the speed, and the accuracy of keeping records. Technologies are used in the transformation process. So they transform resources into outputs. And this is called the processing of technologies. There are 3 types of technology. 2 come from the syllabus, and they are leading edge versus established. And you can also use these as strategies for operations later on. We throw in another thing called bleeding edge, okay, or cutting edge. All right, now established technology, this is already used in industry. It's tried and tested and is quite successful. Downside of that is that everyone uses it. It doesn't give you a massive competitive advantage. Leading edge, okay, or cutting edge, I suppose. Leading edge is technology that's at the forefront of the industry, that's being implemented by the leading companies. And it's very expensive to implement often, but it can give you a competitive advantage. Now, bleeding edge is like leading edge, but it sounds more dangerous, like bleeding edge, like it's been cut. All right, now bleeding edge is experimental technology, something that probably won't work, so you don't want to generally use it in your mainstream things, but to give it a go, a try, because if it pays off, it will create massive profits for your business. And Elon Musk is an entrepreneur that comes to mind with a lot of this bleeding edge technology. Being able to land rockets, on barges out in sea and being able to reuse those rockets. NASA couldn't do it. Nobody thought it was really that possible. And here it is, SpaceX is doing plenty of flights and it is successful and it's paying huge dividends. All right, the next syllabus dot point is task design. This is when each individual task is analysed and broken down into separate steps and allocated to machines, capital, and to employees' labour with the appropriate skills, knowledge, and capabilities. So designing tasks and seeing what computers will do, the capital, the machinery, and what people are going to be doing. Like a principal would do with their subjects, what equipment do we need, what workers do we need, they're designing the tasks. In essence, task design refers to setting out and designing or assigning the job or task that each person or machine is set to complete. Therefore, the purpose of task design is to make sure that the parameters of a job are successfully organised and determined so the right people, the right workers, can complete the work to the standard required. Now, part of task design, you need to understand a thing called a skills audit. And to be able to design tasks, you need to see often what skills they have as a business and what skills are lacking. And maybe employ based on that, recruit and hire based on that. A skills audit is when an audit, an investigation, is conducted to investigate what skills are needed for a job to be completed effectively and to identify this skills gap, what's missing, as I was saying before. So the skills gap that might exist, and thus that will inform the operations manager of what skills are now required. Getting there, I know there's a lot to get through today, but we're looking here at process layout. Again, as always, the syllabus, I don't want to say crap, but a bit shit. Shouldn't probably use those words, but they shouldn't talk about a process layout. They should talk about different layouts, because there are 3 layouts inside process layout. Only one of those is process layout. The other one is product layout. The other one is fixed position layout. But you need to know all 3 of them and know that in the syllabus, the big heading is process layout, even though only one of those is actually called process layout. All right, now those ones are process layout first, second product layout, and third fixed position layout. What's the difference between each? And these are your factory, your business, your school, your hospital's layout. Now, process layout is where all the machinery, the capital, the equipment, etc., is arranged by what they do. That is, the function used to make the good or provide the service. All right, now in terms of process layout, we're talking here about services being provided. Now, the next one is product layout. The product, in terms of process layout, the product moves from department to department, depending on what transformation is needed. Now, this allows for more flexibility and customization of the product. So in terms of process layout, an example is an office where certain roles are placed together, such as marketing, HR, and so on and so on. For process layout, I want you to keep an image in your mind where it might be a school. Students go to whatever department they need to. Think of a high school. You go to business studies. You go down to history. You go over to English, and so on and so on. So you're moving to gain access to what best suits you. It's very customized. Now, this is also the same with hospitals, where you might go to certain things, emergency, maternity, whatever it may well be, to go get x-rayed, to go to triage and so on. That's the first one, process layout. Second one is product layout. What's that? Product layout is where a person moves from station to station. Think with product layout, first one service-based process. With product layout, once you in your mind have this image of an assembly line. All right, product layout is where a product moves from station to station, such as in a car assembly line. Keep again in your mind an image of an assembly line, which each and every product is made goes through the same set of steps in a logical sequential order. That's what you need to have in your mind when you're explaining that for your short answer or your essay questions. The final layout, and again we call them all process layouts as the heading, but it's called fixed position layout, is an approach to plant layout, factory layout, that is designed around the need for the building of very large products, which cannot be moved around in the production process, such as an aeroplane. So I want you to think of a hangar, an airplane hangar. It sits still because it's a big ass thing, and you have people cruising around on this fixed object, this massive good, and they are building it, maintaining it, and so on. It's too big to go through a product layout where you have an assembly line, and it is not a service, so it doesn't go through the same processes of a process layout. So again, those 3 things. Process layout for services, think of a school. Product layout for an assembly line type situation, making a car, watch, etc. Fixed position layout, where you have a big object like a good, like an aeroplane, in its position, people are working around it. And you will choose, as an operations manager, as part of the process, which one best suits your product that you're making. All right, we're getting there, almost. Monitoring, controlling, and improvement. That's another process within operations. Monitoring is the process, not surprisingly, of measuring actual performance against planned performance. What's controlling? This is the comparison of planned performance against actual performance. What? It's the same as above, correct? Controlling is the same as monitoring, but it takes it further. So controlling is the comparison of planned, what you thought performance, against what really happened, actual performance. And, here's the difference, and taking corrective action to make sure the objectives are obtained. So controlling adds that additional step, which is to take corrective action to make sure those objectives are obtained, occur. Improvement refers to the systemic, which is deep and structural reduction of inefficiencies, wastage, poor work processes, and this elimination of bottlenecks. Now, bottlenecks, again, I want you to think of an actual bottle, and they're designed so that if you had a big jug and you just poured it straight into a glass, you'd spill things. Bottleneck is there on purpose to slow the water. I say water, but it's not usually the bottles that I'm having, but water, sure. And it slows that water coming out, slows it down. Think of a highway or roads, 3 lanes going into 2, it slows the traffic. So you want to eliminate those bottlenecks. Now, improvement typically is sought in the following areas. These are the ways to improve operations processes. Time. Can they reduce time? Through the minimization of bottlenecks and assessment of the necessity in all transformation processes and wait times. You want to reduce those lead times. Process flaws. So process flows, and a smoothness of transitions between transforming processes is something that is looked at with improvement. Improvement in quality through the pursuit of quality goals, measurements, and product standards, and trying to reduce these warranty claims, people claiming on warranties. It's one way to look at if improvements occurring. And through cost, trying to reduce the cost per unit of production. And through efficiency is another way to see if improvement is occurring. Through reduction of waste and the creation of greater output per unit input. Now, I've mentioned before KPIs. All right, KPIs that are important to be able to ascertain whether a business has monitored, controlled, and improved well. These are some of the things that are looked at. Operational costs, waste left over from materials, defects, volume of output, speed of manufacturing, and so on. All right, guys, thanks again for listening to another clip. See you next time. Bye.